Welcome to the lecture on Introduction to Machine Learning. In this lecture, we will be covering the following topics. We will start off by defining machine learning and its goals and discuss some example of how it is used in everyday life. We will then move on to explore the different types of learning, including supervised, unsupervised, and reinforcement learning. We will also introduce key terms and concepts that will be used throughout the lecture. We will delve deeper into supervised learning, including classification and regression. We'll discuss the supervised machine learning workflow and provide an example of how these techniques are used in real-world applications. We'll also explore unsupervised learning, including dimensionality reduction for data compression and visualization. We also discuss how unsupervised learning can be used to explore the structure of data and extract meaningful information. We will then cover reinforcement learning, which is a type of machine learning where an agent learns to make decisions based on feedback from the environment. We will provide an example of chess program as a case study. We will then discuss the building blocks of successfully designing machine learning systems, including the predictive modeling workflow. Finally, we will summarize the key takeaways from the lecture and provide additional resources for self-study and further learning. Please follow along with the slide as we progress through the lecture. So let's talk about the general concept of machine learning. So we'll be discussing the general concept of machine learning and its goals. As you know, machine learning is a subfield of artificial intelligence that allows computers to learn from data and improve their performance without being explicitly programmed. The goal of machine learning is to develop models and algorithms that can make predictions or decisions based on data. The model and algorithms can be used for a wide range of applications such as image recognition, natural language processing, and fraud detection. I'm sure you have used lots of machine learning technology in your daily life. And now that we've defined what machine learning is, let's move on to discuss some of those examples of daily applications. Let's look at some of those examples of machine learning on daily application. Why don't we start with spam filtering? In a spam filtering application, machine learning algorithms are used to identify and filter out unwanted emails such as spams. Another example is voice recognition software. I'm sure you're using that on your phone sometimes when you wanted to send a text message, you would use that functionality. ML is used to improve a speech recognition software, making it more accurate and responsive to different accents and speaking styles. Movie recommendation is another example. I'm sure you're using Netflix, other services like Hulu, Amazon Prime videos, or services like that. ML is used to analyze movie viewing habits and recommend new films to users based on their preferences. Mobile check deposits. ML is used to quickly and accurately process check deposit made through mobile banking apps. A lot of banking apps nowadays have that. Another interesting application is estimated meal delivery time by apps like Uber Eats, Dash, and other meal provider services. ML is used to predict how long it will take for a delivery driver to reach a customer's location. Another interesting application that hopefully it's getting in our hands soon and some beta version is available is safe self-driving cars. Machine learning is used to develop and improve self-driving cars, making them safer and more efficient on the road. And the last but not the least, medical applications. ML is used in medical field for detecting a skin cancer with near human accuracy, predicting 3D protein structures and predicting oxygen needs of COVID-19 patients up to 4 days in advance. As we can see, machine learning is used in a wide variety of applications. And this is just a small sample of what is possible. The three types of learning and basic terminology, let's talk about them. Now that we have seen some example of how machine learning is used in everyday life, let's take a closer look at the three main types of machine learning: unsupervised and reinforcement learning. In supervised learning, the algorithm is trained on a labeled data set. where the correct output is already known. Common applications include image classification, speech recognition, and regression analysis. I would love to emphasize the labeled part. That is the part that's really important. That means a supervision is required. A human or someone that has understanding of the data, they need to go annotate the data before we can start doing supervised learning. Unlike supervised learning, in unsupervised learning, the algorithm is not given any labeled data and must find patterns and relationships in the data on its own. Common applications include anomaly detection and clustering, which we will be discussing more about clustering in the upcoming lectures. Reinforcement learning is the last type of machine learning. In reinforcement learning, an agent learns to make decisions by interacting with the environment and receiving feedback in the form of rewards or penalties. Common applications are including game playing and robotics. Now that we've covered the three main types of machine learning, let's move on to discuss the building blocks of designing machine learning systems. Well, why not we first start by focusing on supervised learning, machine learning workflow, right? And then discuss this building block of that machine learning as supervised learning. So in supervised learning, we are given a labeled dataset where the correct output is already known. In this slide, we're going to cover the basic steps involved in a supervised learning project, including the importance of labeled data and the process of separating the data into training and test data set. So data collection and preparation is one of the most important steps of any machine learning project, including supervised machine learning. We begin by collecting and preparing data that will be used to train the model. This includes splitting the data into training and test sets. And I can't emphasize how important this is and how many things can go wrong if the test and training data they actually mixed up, or the test split into the training or spell there. The training set is used to train the model, while the test set is used to evaluate its performance. And that's why it's very important that the test set should be separated. Feature extraction, that's the next step. We identify and extract the relevant features from the data that will be used as inputs to the model. This step is crucial for improving the model's performance and generalization. Next step is model selection. We then select the appropriate algorithm and tune its parameters to best fit the data. Last but not least, we evaluate the performance of the model on the test data set, the separated test data set which I mentioned earlier, using various evaluation metrics. This step allows us to measure the model's accuracy and determine if it is suitable for the deployment. And by deployment, I like deploying it as an application or as a service when it's interacting with the actual users. Now that we covered the basic steps involved in a supervised learning project, let's discuss two types of supervised learning problems. Again, as I discussed in the previous slide, in the supervised learning, we're giving a labeled data set where the correct output is already known. In this slide, we are actually now going to cover the two most common tasks of supervised learning. And those two tasks are classification and regression. So what is basically classification and regression? So in classification, the goal is to predict a categorical label or class for a given input. For example, think about an image classification problem where you have an image and the goal is to assign an image to one of several predefined categories such as dog, cat, car, etc. Could be this image of me in the video that the system is looking at, and the system is supposed to say, hey, there is a person on the screen. Regression would be the other type of supervised machine learning. So in regression, the goal is to predict a continuous value for a given input. For example, in stock prediction, the goal is to predict the closing price of a stock based on its historical data. But it's a very hard problem. It's not easy to solve it. So don't even think about just learning regression and apply it to the stock market and be the next billionaire. It's much harder than that. But that's a good example. Now that we've covered classification and regression, let's move on to discuss further about classification and regression problems. In this slide, we're going to take a closer look at classification, a subcategory of supervised machine learning. Classification is a supervised machine learning task that involves the predicting of the categorical labels for new instances or data points based on past observation. The goal of classification is to assign new data points to one or more predefined classes or categories. Class labels are unordered and can be understood as the group membership of data points. An example would be the spam filter, which is a binary classification task, where the machine learning algorithm learns to distinguish between two possible classes, spam and non-spams. Now that we've covered the basics of classification, let's move on to the regression. Now in this slide, we're going to take a closer look at regression, which is still a subcategory of supervised machine learning that deals with predicting continuous outcomes. So regression is a supervised machine learning task that involves predicting a continuous outcome based on a set of predictor or explanatory variables. The goal of regression is to find the relationship between predictor variables and a continuous response or target variable in order to make a prediction about new data. So the input for a regression model are predictor variables, which are also known as features, and the output would be a continuous response or the target variable. A good example would be stock price prediction, which we discussed about it, and that's a common good example application for regression. The estimation of meal delivery time could be another good example of regression. Well, now that we covered the basic of regression, which is another supervised machine learning algorithm, let's move on to discuss about the second type of machine learning problem, which are unsupervised learning, where, as we discussed earlier, there will not be any labeled data provided to the algorithm. In this slide, we're going to take a closer look at unsupervised learning, a subcategory of machine learning that deals with unlabeled data or data of unknown structure. Unsupervised learning is a subcategory of machine learning that deals with unlabeled data or data of unknown structure. Unlike supervised machine learning, which we discussed in previous videos, no labels are provided, and unlike reinforcement learning, which we will talk in the next videos, no reward function is defined. The goal of unsupervised learning is to explore the structure of the data and extract meaningful information without the guidance of a known outcome variable or reward function. The inputs for unsupervised learnings are unlabeled data or data of an unknown structure. And a good example for unsupervised learning would be a clustering algorithm. Clustering is a common unsupervised learning task where the goal is to group similar data points together. As you see in the figures on top right, you would see that the different data points are mixed together, and clustering algorithms are able to understand and cluster them, group them together. Now that we've covered the basics of unsupervised machine learning, let's move on to discuss some common algorithms and techniques that's used in unsupervised tasks. Dimensionality reduction for data compression, which is also being used for sometimes for visualization as well, is the subject of this portion of conversation. And in this slide, we're going to take a closer look at dimensionality reduction. And again, this is a subfield of unsupervised machine learning that deals with high dimensional data. And you usually do that for compression. And a good example of compression is when you have a very high dimensional data and you want to basically visualize this. And we human, we can only either look at the screens or 3D, I guess, when we are actually walking around, seeing things, or when we are using the virtual reality glasses. Now, dimensionality reduction is a subfield of unsupervised learning that deals with reducing the number of features or dimensions in the data while retaining most of the relevant information. Now, this is done to overcome the limitation of storage and computational performance of machine learning algorithm, or as I said, it could be actually done for exploration and visualization, where we want to get the sense of data and we would love the human to take a look at it. The goal of dimensionality reduction is to compress data in a smaller dimensional subspace while retaining the most of the relevant information. The input for dimensionality reductions are high dimensional data. Well, let's talk about an example. An example would be principal component analysis, or PCA, which is a technique to reduce the dimensionality of the data while retaining most of the relevant information. This technique is often used in feature processing to remove noise from data, which can degrade the predictive performance of certain algorithms. Now that we've covered the basics of dimensionality reduction, let's basically move on to basically the next topic, which is about reinforcement learning. So, as we discussed, reinforcement learning would be the third type of machine learning. So, in this slide, we're going to take a closer look at reinforcement learning, which is a subcategory of machine learning that deals with learning from an environment through trial and error. Reinforcement learning is a subcategory of machine learning that deals with developing an agent that improves its performance based on interaction with the environment. The goal of reinforcement learning is to learn a policy, which is a sequence of action that maximize a reward signal. The input for reinforcement learning are a reward signal that provides information about the current state of the environment, and a reward function that measures how well the agent's action align with the desired outcome. Now, I understand this sounds very complex, and I promise you it's not as bad as it sounds. And unfortunately, in this course, we're not getting to talk about reinforcement learning in details, but hopefully there will be future courses that we will develop that delve into this subject. But let me give you an example of a reinforcement learning would be game playing agents is a common application of reinforcement learning, where the goal is to learn a strategy that maximizes the reward or score. So that could be like an Atari game, that could be any type of game where you can actually train the agent to kind of play that game. Again, it's important to mention that in reinforcement learning, the agent interacts with its environment and receives feedback in the form of reward or penalties, which it uses to adjust its behavior and improve the performance over the time. Now that we have seen a concrete example of reinforcement learning, let's take a look at the building blocks of designing successful machine learning systems. In this slide, we're going to take a closer look at the predictive modeling workflow, which is the process of creating a machine learning model. Now, this slide is a very visual slide, so I would love to take a pause and let you digest the slide before I continue. The predictive modeling workflow consists of several steps, including pre-processing, training, and selecting a predictive model. The first step in the predictive modeling workflow is pre-processing, which includes cleaning and transforming the data to make it ready for training. After pre-processing, the next step is training, which involves using a pre-processed data to train a machine learning model. After training, the final step is selecting a predictive model, which involves evaluating the performance of different models and choosing the one that performs best. Now, this is just a general slide at this stage for you to have an appreciation for the overall process, but during the course of this lectures and in future lectures, we will delve into developing algorithms that follow these flowcharts, and we'll get into every stage of this process and workflow. We're going to summarize the key takeaways from the lecture on the introduction to machine learning, and that would be the final slide of this module. Now, the key takeaways would be in this set of slides that we provided to you would be the number one would be we covered the general concept of machine learning and the three types of learning: supervised, unsupervised, and reinforcement learning. We also discussed the building blocks of successfully designing machine learning systems, including a predictive modeling workflow. We provided example of daily application of machine learning, such as spam filters and medical applications. We also introduced a number of key terms and concepts, including regression and classification. We covered a lot of ground in this introduction to machine learning, and there's still so much more to explore. Keep an open mind and be ready to learn more in the next lectures.